This one's yeah, this one's not even. This is a good one. All right, so the integral from 0 to 1 of e to the x is e minus 1. That's the area. That's this blue area. So very good. Okay. With this knowledge, evaluate each of the following integrals. Well, here, if you switched around the limits, so like first, if you switched around the limits of integration, e to the x dx, that just, it's the same area, it's just negative. So this will be negative e plus 1, right? If you just put a negative outside and you distribute it. So that would be that. But then they're also multiplying it by 3. So then it would just be times 3, right? Because you can put the 3 out there. So this would be negative 3e plus 3. So that's easy. Easy on that one. Easy. This part corresponds to the shifting principle. We're shifting to the left 1, right? We have the e to the x function, which is something like that, e to the x function, and we're shifting it to the left 1, right? Yeah. So if we're shifting that to the left 1, and we shift the limits, we're shifting the limits, right? Back 1, back 1. Okay, so this one just shifts back 1 and then still multiplied by 3. If the whole entire area that we're looking at, or whatever it is, it's actually here. We're taking this and we're just shifting it over. It's the same exact area. It's just now shifted back 1, right? So, and then we're multiplying it by 3. So this one equals 3e. It's not the same as this. It's the same as this multiplied by 3. So 3e minus 3. So that's that part. Let me get the other picture. And so that was that one. Whoops. That one's done. That one's done. E to e, that's just 0. Anytime you have the same number, like, whoops. If you have the graph, just the area of a line is just, it's nothing. There is no area. So this one is just 0. Hopefully that's good. I don't know if there were more than that, but I think that was all for the picture. I'm just going to do the other photo, or the picture they sent. All right. Let's take a look at that one. So, evaluate, use the graph as an aid. So I'm just going to graph that. I'm going to graph y equals the absolute value of x minus 2. The first thing I do is I just graph y equals x minus 2. And the more accurately I can graph it, the better. So I'm going to get a graph paper. What I'm going to do is I'll graph y equals x minus 2. So that's just 1, 2. Slope of 1. 1, 1. And there we go. But it's an absolute value graph. So any values that were going to be negative, which are all of those except for that 0 point, all of those values are just going to be flipped over the x-axis. They're going to be changed to positives. So really, I have that. So there we go. And there's my graph. Cool. Or that's just y equals the square root, the absolute value of x shifted to the right 2. That's what that means. And there we have it. So, sweet. Now let's interpret this. The area from -1 to 4. Well, from -1 to, that's 3, 4. So I'm looking for this area here. Well, I have 3 by 3 and 2 by, looks like 2. Yeah? So 1/2 times base times height. That would be 1/2 times 3 times 3 plus the other area, which is 1/2 times 2 times 2. And I get, 9 over 2 plus 2, which is 4 over 2. Right? This is 4 over 2. 9, that's 13 over 2. Over 2. So that's the area there. I hope that's right. But that's how you do it. You just graph that and then be done. Did I do it right? 1, 2, 3, 4. Yes. Back 1. Yes. 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 I hope that helps. See you later.